All right, all right, all right, all right. Now we're ready. Okay, so we're doing split graphs. What we're going to do is, let's just jump right into an example. I want us to graph f of x is equal to 3 if x is less than or equal to 0. Oh, I'm not projecting. And split rule graphs, yep. And -3 if x is greater than 0. So I'll give you a second to write that down. Okay, so what you want to do is you want to treat these as two different graphs. So I'm going to have f of x is equal to 3 first if x is less than or equal to 0. Now remember, f of x is interchangeable with what? Y. So this is saying y is equal to 3. What kind of graph is y is equal to 3? It's a horizontal line, exactly. It is a horizontal line. So let's get this sketched. All right, so we're going to have y is equal to 3, which is right here. But this is not my graph because my domain is restricted. What are they saying? They're saying if x is less than or equal to 0. So where is x less than or equal to 0? Isn't that this part of that line? So the other part gets erased. There's no line there because of my restricted domain. Right, then it's saying y is equal to, sorry, let's do this next part. So now the next part is saying f of x is equal to -3 if x is greater than 0. So remember, f of x is interchangeable with y. So now we have y equals -3. That's going to be a horizontal line at -3. But again, my domain's restricted. It's only -3 when x is what? Greater than 0. Can it be equal to 0? No. So what you're going to do is you're going to draw an open circle on -3, 0. And then we want where x is greater than 0. So which way is this line going? To the right. And this is how my split graph looks. All right, let's do another one. Going to have f of x is equal to -1 if x is less than -3, 0 if -3 is less than or equal to x, which is less than 0, and 1 if x is greater than or equal to 0. All right, let's see what's going on here. So I'm going to have y is equal to -1 if x is less than -3. 1, 2, 3, 4, 5, 6. All right, so y equals -1 is a horizontal line, but this time, where are we starting? At x equals -3. So 1, 2, 3, -1. And now, is there going to be an open circle or closed circle at -3, -1? Open circle. And then which way is my line going? To the right or to the left? We want x is less than -3, so we're going to the left.
Why did you start? How did you determine where the line starts?
By the domain. So the whole line that we were sketching was y equals -1, which if it wasn't restricted, it would have been this, right? But they are restricting it because they're saying x is only if x is less than -3. So where is x -3? Right over here. So we only want the left part of that line. You're welcome. No, it's not coming back. All right, the next part of this graph, it's saying y will equal 0 if -3 is less than or equal to x, which is less than 0. Now, y equals 0, isn't that the x-axis? Right, but now the graph is only going from -3 to 0. So I'm going to have a closed circle on -3. I'm going to have an open circle on 0, and then the horizontal y equals 0 line between them. And the last one, x will equal, y will equal +1. Y will equal +1 if x is greater than or equal to 0. So I'm going to go to where y equals +1. I'm going to put a closed circle on 0, 1, and then we're going to the right this time. All right, it's not always just going to be horizontal lines. It would be nice if it were always just horizontal lines, but it won't be. So let's change it up a bit. Let's say we have f of x is equal to -1 if x is less than -1. The negation of the absolute value of x if -1 is less than or equal to x, which is less than or equal to 1. And -1 again if x is greater than 1. Okay, I'm actually going to start off with this one. Do we agree this is a frowning V? It's a V that's opening down, right? Okay, so now I'm going to start here. So we have y is equal to the negation of the absolute value of x if -1 is less than or equal to x, which is less than or equal to 1. Now we know I'm going to have my turning point because it's not shifting at all. I'm going to have that turning point at 0, 0. And we know it's going to open down. The problem is my domain is restricted right here. So this is a V that's opening down, a frowning V, only between -1 and +1. So what we need to do is we need to figure out what's happening at the point where x is -1 and +1. So what do? I set up a table and I test those points. So here's x, here's y equals the negation of the absolute value of x, and then we'll get our y coordinate, our corresponding y coordinate. So the first thing I want to do is test when x is -1. When x is -1, I'm going to have y equals the negation of the absolute value of -1. Well, what is the absolute value of -1? +1. So now we're going to have the negation of +1, which is just -1. So my starting point is going to be -1, -1, and that's a closed circle here. And then the ending point, now we test +1, y equals the negation of the absolute value of +1. Is the absolute value of +1 -1? No, it's such a big mistake that people make, right? Absolute value is always positive, right? It's distance. It's the distance on a number line from 0. Distance is always positive. So the absolute value of +1 is +1. So now we have the negation of +1, which is -1. So here's another closed circle. Why am I making them closed circles? Does anybody know versus open circles?
All the signs are less than or equal to.
Good, because all of the signs in that domain are less than or equal to because of those lines underneath the crocodile mouth. That's why I'm making the closed circles. So this is my frowning V. I cannot extend beyond that because of the domain restriction. All right, now let's go back. Danny.
So for like the chart, how do you know that x is equal to -1?
Oh, because of the domain. So they're saying this V between these two numbers. So on our domain. So it's going to be a V between -1 and +1. So this is our start, this is our end. So that's why I plugged in -1 for x to see what's happening where it starts and +1 to see what's happening where it ends. We already knew what was happening at 0 because that was our turning point. Okay, now let's go back to the rest of this graph. So now they're saying y is equal to -1 if x is less than -1. Well, do we all agree y equals -1 is a horizontal line at -1? But now it says if x is less than -1. So what that means is they want an open circle right here. But what's already there? A closed circle. A closed circle trumps an open circle. So if there's supposed to be an open circle from one thing and a closed circle from another thing, you keep it closed. So closed circle trumps an open circle. So now we're just going to go y is equal to -1 if x is less than -1. So that's going this way. And there's one more part of this graph. The last part is saying y equals -1 if x is greater than 1. So what happens here? Well, we know y equals -1 would be a horizontal line right here. But now they're saying if x is greater than 1. So here's where x is 1, but it should be an open circle, but because there's a closed circle already there, what do? Keep it closed. Keep it closed. And then we just get the other part of our line in. All right, next one. Okay, let's start with that first one. We're going to have y equals 2 minus x if the absolute value of x is less than 2. Well, do we all agree this is an equation of a line? 2 minus x. It's just in the wrong format. So I'm going to rewrite this. Y is equal to negative x plus 2. Now this looks a little bit more like y equals mx plus b. So we can sketch that line if we wanted to. But now our domain is restricted in a very weird way. It's saying the absolute value of x is less than 2. Danny, is your hand up? No. Okay. So if you remember way back when from Unit 1, anytime you have an absolute value and an inequality, we're going to separate it into two. So this is going to be x is, what was this? X is less than 2, and then some word, and x will be greater than the negation of whatever number that is. Now remember, if it were a less than, it was going to be an and problem. And if it were greater than, it was going to be an or problem. So this is x is less than 2 and greater than negative 2. So what does that mean if x is less than 2 and it's greater than negative 2? It has to be between those two numbers. So we would write this with x in the middle. X is less than 2, greater than negative 2. So negative 2 is less than x, which is less than 2. So we could get this line going. Just going to make this into graph paper. Where's my paper? Yes.
Why can't they include negative 2? Include 2.
Because the original one was just less than, not less than or equal to. Okay, so I got my graph paper. Now I'm going to sketch. There, better graph paper. Let's do bigger one. Do bigger graph paper so you all can see it. Do this one to go bigger. There we go. All right, so here I am. All right, so here my m is negative 1 over 1. My b is positive 2. What I'm going to do is I'm just going to sketch the whole line and then I can erase according to my domain, if that makes it easier. So I'm going to start off with my y-intercept, which is 2. And then from my 2, I'm going to rise and run according to my slope. So we're going to go down 1 to the right 1, down 1, right 1, down 1, right 1. Let's keep going. And then we'll go up 1, left 1, up 1, left 1. Keep going. All right, so here are the points for my line. But now this domain of this line is restricted. They're saying this line only exists between which two x values? Between negative 2 and positive 2. So that means everything else goes away. So we want everything between negative 2 and positive 2. Everything else goes away. But what kind of point should be on negative 2 and positive 2? Open circles. So I'm going to go ahead and make this an open circle and make that an open circle. All right, there's another part of this graph. The other part of this graph is saying y will equal 0 if the absolute value of x is greater than or equal to 2. So remember, anytime you have an absolute value inequality, we're going to split it into 2. So we're going to say x is greater than or equal to 2, some word, and then x will be less than or equal to the negation of whatever that number is, -2. Because the inequality sign is greater than, it's not going to say and anymore. What do you think it's going to be now? Or. So x is greater than or equal to 2 or less than or equal to -2. So now let's see what this sketch looks like. If I'm at y equals 0, isn't that the whole x-axis? But now I'm only where x is greater than 2. Well, greater than or equal to 2. Isn't that right here? Where we have an open circle. That's x is 2. But now this is saying greater than or equal to 2. So wouldn't that be a closed circle? So since there's already an open circle there, now I need to put a closed circle there at that same spot. What am I going to do? Closed or open? Close trumps open, right? So we're going to open this. Oh, sorry, close that, and then we're going to the right. Or x is less than or equal to -2. So that's a closed circle here going to the left. What about the points between those two red points? What should I do with that? Erase them, exactly. And that's our graph. All right. I have 2 for you to try. Are you ready? 2 for you to try. So this first one, this is the same. This is the same as y equals negation of the absolute value of x plus 1, if that helps, rewriting it like that. So that's the first one, and then I'll write out the other one I want you to do. All right, so those are the 2 I want you to do. Try your best, and then we will go over them.
Yeah, less than or greater than. What's this? What speed run this problem? What's this?
Can we go over the first one? No, not yet. Okay.
Calm down.
Calm down? You calm down. James.
No, not you.
Why are you getting angry?
Oh, there's two.
Yeah, are you gonna
Alright, so you gotta do that chart thing. Maybe you don't need that.
Actually, I think you're right.
Yes, but we need that chart.
Yeah, you need the chart just like we did in the other absolute value.
Yeah.
One.
Yeah, I still have the
I mean, you could figure it out in your head.
Yeah.
Like, you know, smart. So we put -1 and 1 is like -1 and -1.
James, are you talking to yourself here?
Yes.
Calm down, James.
Yeah, let me see if
I got 0.
it's an A, yeah, for one. And then one of them's a line, and then the other one, 2 lines, one opposite direction.
Yeah, for my chart, I got 0.
Yeah. Wait, mine's float. This one's a float. This isn't it? An X. It's greater than 1. No, it should be that. Yeah, but that's when X is 0.
All right, let's go over this. So for this first one, we have y is equal to the negation of the absolute value of x plus 1. And that's under a restricted domain if -1 is less than or equal to x, which is less than or equal to 1. So I'm going to start there. So this is a frowning V that has been shifted 1 unit up. So I know this is my turning point right here at 0, 1. Now, I'm starting this V at -1 and I'm ending it at +1 for x. So I'm going to go and make my chart. So I'm going to see what happens at -1. So y will equal the negation of the absolute value of -1 plus 1. Well, absolute value of -1 is +1, but then you bring down that negative. So -1 plus a +1 is 0. So we're going to have, when x is -1, y is 0. So I'm actually, you know what? I'm going to make the intervals of a half, both up and down. So I'll say this is a half, this is 1. This is a half, this is 1. 1. All right, so these are closed circles, so I'm a closed circle here, -1, -1/2. All right, then we're going to do the same thing with +1, so y equals the negation of the absolute value of +1 plus 1, so that's -1 plus +1 is 0, so then we're here. So that looks something like that. All right, so now the rest of this graph is going to be y equals a half if negative a half is less than x, which is less than positive a half. So what does that mean? That means I'm going to be open, well, it would have been open circle here and here. But I believe, does that fall on the line? I don't know. We test to see if it fell on the line. Let's see what happens when x, for this top one, when x is a half. Let's see what y is. Y is negative a half plus 1, which is 0.5. Yeah, so this is on the line. So because it's on the line, closed trumps open. So these would be closed circles here. And that's the first graph. All right, and the last problem for today. So the first one is going to be y is equal to 0 if the absolute value of x is less than or equal to 1. So this means x is less than or equal to 1. Is it an and or an or? And x is greater than or equal to negative 1. So because it's an and, we're going to write it all together. So x is in the middle. X will be less than or equal to 1 and greater than or equal to negative 1. So we will sketch this. So we are between negative 1 and positive 1, and it's right between them, right there. Oh, I messed up my line. There we go. Okay, so now what's the other part of this? We're going to have y equals x minus 1 if the absolute value of x is greater than 1. So we're going to have y equals 1x minus 1. If x is greater than 1, what word should I put in between now, and or? Or x is less than negative 1. So this is saying my y-intercept is negative 1, and then my slope is 1 over 1. So up 1, right 1, 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 down 1, left 1, down 1, left 1, down 1, left 1. But now it's saying if x is greater than 1, so that's going this way, or x is less than negative 1, which is going this way. So everything between there, I'm now going to erase. There's one more thing I need to look at. What else do I need to look at? Any ideas? Go up. Closed circle, open circle, exactly. Now, this whole part of my graph, my line, should be open circles. But here, wasn't there already a closed circle there? Closed trumps open, so this one will stay closed. But on this one, what should I turn that into? An open circle. All right, we are done for today.